Without further ado, unless I missed anything, Cheryl or Austin, let me know if I did miss anything. But otherwise, we already have our first speaker lined up. We'll have Dr. Carrie Garrison-Laney up first, followed by Mr. John B. Gargett, sorry. And so I'll introduce our first speaker, and then we'll see how much time we have. We might have a little bit of time for a Q&A, and then we'll move into our second speaker. So once again, thank you for joining us. And so Dr. Carrie Garrison-Laney is the Tsunami Hazardous Specialist and PMEL liaison with the Washington Sea Grant, where she combines her passions, tsunami science, communication, and scientific education. Carrie's research as a graduate student included work on identifying and dating paleo-tsunami deposits in California and Washington, numerical modeling of tsunamis, and using intertidal diatom ecology to study past tsunami inundation events and sea level change. She also taught students in middle school through graduate school. Somebody needs to mute themselves. Through graduate level on tsunami deposits and earthquake hazards in Washington. Carrie earned a bachelor's degree in geosciences from San Francisco State University, a master's degree in environmental systems from Humboldt State University, and a master's degree in human-centered design and engineering, and a PhD in earth and space sciences, both from the University of Washington. So without further ado, Dr. Carrie Garrison-Laney, please take it away.
Thank you. Thanks for that nice introduction. I probably shouldn't have stayed in school so long. It takes too long to say all that stuff. Anyway, thanks so much for having me. I'm delighted to talk to you. I'll give you some tsunami hazards, kind of specifically customized for Whatcom County. So maybe there'll be some things here that you didn't know about. But without further ado, I will get going. Also wanted to say that I cannot see chats or raised hands, so if somebody needs to interrupt me, I mean, hold questions till the end, but let me know if there's a technical issue. Okay, let's go. Okay, so I'll be covering today our tsunami sources in Washington and specific to Whatcom County, as I mentioned. I'm going to show you a little bit of some of the tsunami modeling that's been done for the area and talk a little bit about the model that we use. I'll be talking about some geologic evidence of past tsunamis. I'll show you some of that, and end with just a little bit of information about some new ongoing work that's going on, and then take questions.
Carrie, sorry to interrupt you, but there's some folks saying they're having a really hard time hearing you. Is there a way that you could...
Oh, but you know, I kind of want to hear what these people are saying. They're saying important things right now. I just want to listen to this for like 30 minutes, and then I'll meet you at the Chantal at 6 to be on foot.
Okay, that's somebody that's got a mute, I think.
Sorry about that. Someone else was not on mute, and I fixed that, but I'm also, I'm speaking with you. I'm just watching the chat box, and people are saying they're having a hard time hearing you, so.
Okay, let's see. I'm gonna turn my volume up as high as it'll go.
Okay.
How is that? Better?
Let's just keep going and see how folks are responding here.
Okay. Okay, so we in Washington get tsunamis from a variety of sources. We get tsunamis from offshore, from the Cascadia subduction zone, off the Pacific coast. We know we can also have tsunamis form when there are earthquakes on some of our shallow crustal faults, like the Seattle Fault, the South Whidbey Island Fault. We can also have tsunamis that are generated by landslides, either landslides into water or underwater landslides. And these can be triggered by earthquakes, but they can also happen without an earthquake trigger. We know we live in a really landslide-prone part of the world. And we also can get tsunamis from around the Pacific. One example is the 1964 Alaska tsunami caused some flooding, damages, and fatalities in Washington and also Oregon and California. Two other sources that I'm not really going to talk about because they're not really pertinent to us is tsunamis caused by volcanic eruptions. And then I hope the last one's not pertinent to us, but with the way 2020's gone, you never know. But then the last one would be asteroid, meteorite crashing into the ocean causing tsunamis, but we're going to ignore those for now. This map is showing locations where there are known tsunami deposits. And I could add some more points to this map, but these are just published science papers that have information about tsunami deposits, their ages, their characteristics, and in some cases, where their sources were from. And along the Pacific coast, it's not a surprise that most of those are probably from Cascadia. We may have a random Pacific tsunami from some other place in there as well. But when you move into the Salish Sea, you have a situation where there's lots of potential sources, not just Cascadia, although we do know now that Cascadia tsunamis definitely get into the sound. So sorting out some of our Salish Sea sites where the tsunami deposits came from is it's like the main part of my research. Okay, in terms of our seismic tsunami sources, we've got three major sources. And in this slice through Washington State, you can see we get earthquakes generated along the plate boundary between the North America plate and the Juan de Fuca plate. We get earthquakes that happen on these shallow faults like the Seattle Fault, and we get earthquakes that are deep within the subducting Juan de Fuca plate. And they don't cause tsunamis directly, but they can cause landslides through shaking. So I'll talk about each one of these in a little bit of detail. For Cascadia subduction zones, so this is the tsunami source we tend to worry about the most because subduction zones make the largest earthquakes and therefore the largest tsunamis. And in terms of probability for the next 50 years, for a magnitude 9 earthquake, probability is about 10 to 14%, which is low, but it's not that low. I mean, that's fairly likely. And then for a magnitude 8, it's even more likely, 30% chance. And you may have heard of the recurrence of these events. Whoa, okay. You may have heard of recurrence for great Cascadia earthquakes. And the numbers change here and there, and that's as new work comes out. But we have a model of Cascadia recurrence where the recurrence increases as you move south. So in the southern part of Cascadia, off the coast of California and Oregon, they have a greater number of earthquakes, not as big, but then the big ones, the magnitude 9s, those are the ones that affect the entire subduction zone. And so the southern part of Washington has a recurrence of about 430 years, and the northern part is about 500 years. And what recurrence means is it's basically just the amount of time divided by the number of earthquakes. It doesn't tell you when you're going to get the next earthquake. It just gives you an idea. Now, during a subduction zone earthquake, there is deformation on the surface of the earth or on the surface of the seabed if you're looking at an offshore fault like Cascadia. And on this map, what you can see is a plot of the kind of deformation you might expect, where you've got uplift shaded in red, and you've got subsidence or sinking of the surface shaded in blue. And then notice that the subsidence kind of hugs right along where the coastline is. And if we look at a kind of a cartoon of what might happen out underwater, this uplift of the seafloor, which is shown right over here, this mass of earth pushes up and it displaces all the water over it. And that's what generates the tsunami, which then propagates out in all directions. And the coastal areas out on the Pacific coast get sort of a 1-2 punch, because not only do they subside during subduction zone earthquake, but then they get the tsunami minutes after that. So now where we are inland here, well, where I am, I'm in Seattle, and where if you're up in Whatcom County, you don't have to worry about coastal subsidence from a Cascadia earthquake, but you do have to be concerned about the tsunami. Now, we haven't had a Cascadia earthquake since 1700, the year 1700, so 320 years ago. So how do we know this happens? Well, we know because of geologic evidence like this. So this is from a site in Southwest Washington, and what you're seeing here is geologic evidence for coastal subsidence and tsunami. And I hope my cursor shows here, but this brown layer here is a forest soil, and then these stringy layers on top of that are sands deposited by a tsunami. And then everything above that, this gray or oxidized orange mud, this is intertidal deposits that accumulated in the decades to centuries after this whole entire landscape was lowered into the intertidal zone. And one thing to point out with this is these different sand layers are thought to represent individual waves in the one tsunami event. So a tsunami is never just one wave, it's a series of waves that can continue for hours. So this is a pretty spectacular site. And along other sites in Southwest Washington, the sites that are shaded in green here, these are the sites where we've, Brian Atwater and others put together an earthquake history for Cascadia. This timeline here along the top is showing the up and down of the land level on the coast. So I told you everything subsides suddenly during the earthquake, and then it slowly rises up again over time between each earthquake. And the green boxes are showing the age range for the event. Some of the events we know really well, like to the hour, like the most recent one. That's a whole extra talk, so email me if you want more info. And then some of them we don't have very good age control. These ages are determined by radiocarbon dating. And then these earthquakes have letter names that Brian gave them. So these are the land records of Cascadia earthquakes. And we also have offshore records of Cascadia earthquakes, which is out in the deep ocean canyons. There are disturbance layers called turbidite deposits. And basically offshore where the plate boundary is, that's where the shaking is the most intense during an earthquake. And that shaking dislodges sediment. That's a density flow. It's denser than the ocean water, and it flows down into submarine canyons. And over time, a long record of earthquakes is formed. And we can go back 10,000 years in Cascadia earthquakes looking at turbidites offshore. And you've probably seen this Cascadia earthquake timeline. And this was put together by folks in Ian Madden at Dogami at Oregon. And this has got all of the Cascadia earthquakes that are represented by turbidites. But we don't have to consider all of those, especially when we're thinking about sites inland like Whatcom County. What we really need to consider are sites that, or earthquakes that happen off of the Washington coastline. So I put this timeline together. And Each one of these bars represents one turbidite deposit, which are named T, turbidite 1, turbidite 2. So turbidite 1 is the most recent earthquake event in 1700. And then you can see we can go all the way back to turbidite 18, and there's a couple other extra ones thrown in there with question marks where there's uncertainty. So for Washington, this is why our recurrence for these bigger earthquakes is a wider range than what you'll see quoted for Oregon. And those are the numbers that tend to get into the news a lot, the recurrence interval for Oregon. So that always causes confusion. So the good news is not as frequent, probably, but I can't promise anything either. Now you might think, well, what does a Cascadia tsunami do when it gets into the Salish Sea? And this plot on the left is showing maximum wave heights for a Cascadia tsunami coming into the Strait and into Puget Sound and up into the Georgia Strait. And what to take away from this is that it's not the wave heights aren't going to be the same everywhere. Because there is so much variation in water depth, and there's so many intricacies of islands and shorelines. Lots of wave refraction occurs, and so places where there's very deep water right near a coastline, like along the city of Seattle, really don't expect to see much of anything from a Cascadia tsunami coming into the Sound. But you'll see other places, including Bellingham Bay and Discovery Bay and Port Townsend Bay, and even all the way over here in Hood Canal and the Port of Tacoma. Those are places where they should be ready for some Cascadia tsunamis to cause at least dangerous currents and maybe not inundation. Now, the kind of inundation that'll happen in the Sound isn't going to be like what happens out on the coast where the waves are much higher. And this model, this L1, which you'll hear about on occasion, because this is the model earthquake that's being used by DNR for their latest beautiful updated tsunami inundation and current maps. This map is showing what the deformation for that L1 earthquake looks like. And so in case you ever heard anyone talking about L1, well, that's just the input for the tsunami model. That's what we assume the earthquake does in that model. Now, so DNR, Washington Geological Survey, has put together some beautiful maps and animations, and this is one for Bellingham. And so this is wave amplitudes, and in this animation, the wave peaks are the warm colors, and the cool colors are the wave troughs. And some other things to know about this is it's sped up, and it's kind of the vertical range of difference is kind of compressed here. And we're about to have an earthquake offshore, and there goes the wave. So some of you may have seen this before, but you can see there's a leading trough. These blue colors show a drawdown, and then the crest of the wave goes behind that. And down in the lower right corner, that's the time since the earthquake. So we can see a drawdown in Bellingham Bay around 2 hours after the earthquake, and then the wave crests really coming in around 2.5 or 2 hours and 40 minutes. That's the first wave, the first trough and the first wave. And then you get a second trough in this simulation. And this goes, I don't remember how long this one goes out to, but even if you model out 12, 15 hours, you still see wave activity. And that's because lots of waves are coming in and bouncing around. And so this gives you an idea of what that looks like. And this is a part of the latest map the modeling that was done to show you that animation was also used to make these static inundation maps, which you can download right off of the DNR webpage, which I'll give you the URL for at the end. But this just shows you some of the flooding depths, the depths of the water on land for a few select places. This next animation is showing the current velocities. And okay, good, that's running. So in this, we're not looking at wave heights, we're looking at how fast the water's moving. And the more purple colors are above 6 knots, and then 3 to 6 is that middle color. The light one is slower, and then up to 9 knots is shown on here. And again, the earthquake time lapse in the lower right corner. So earthquake any moment, and okay, there it is. Now in this animation, we just skip right ahead to Bellingham Bay because we don't need to see all the currents in the strait. But with this animation, it's a little bit more subtle, but you can start to see places where you start to see a little bit of those warm colors coming in. And this is just showing you that the water is really going to be moving around quite a bit. And it's going to get to some pretty high current velocities on these purples coming in. So these are places where the water is going to be moving really rapidly. And you can probably see these little vortices swirling around here at the bottom. So the kind of tsunami modeling that we can do now, it's pretty cool. It's pretty exciting, and so this just, and you can watch all of these on their webpage. And we actually this is actually going to be redone because you can see how it cuts off up here across the Lummi Nation, and that's actually the new model is going to go further to the north. All right, we'll move ahead here. Now, shifting gears, a new source I want to talk about now are shallow earthquake sources. These are a little bit more likely to have one in the next 50 years, maybe. 15% overall, and that means for all shallow faults around the area in which there's a lot, as you'll see. 15% chance of a magnitude 6.5 or greater. It's still a really big earthquake. It's not a magnitude 9. And then how often do these recur? We don't know. It can be in hundreds of years time frame to thousands of years. There's lots of different faults. They all have their own characteristics, and they all have ruptures on their own time schedules. And we just don't know the answers for all of them. Now this map's showing some of these faults, and the Seattle fault zone right here, the South Whidbey Island fault, and up here Birch Bay fault. These numbers are showing when the most recent earthquake happened on that fault. And for some of these, that's the only one we know about, is the most recent one. And these cause tsunamis. These we know cause tsunamis. Some of the other ones may have, but these are ones we feel pretty confident about. So looking at the Birch Bay fault, it runs this way. There's a portion of it that goes offshore, and some geologic evidence of tsunami and also land level change can be seen in this marshy area next to Terrell Creek in Birch Bay. And what you're seeing here, okay, so this is a core, photo of a core, and then this is a sketched interpretation of the geology there. And hard to see in this photo, but this is the ground surface before the area was subsided or lowered, and at about 66 centimeters, so maybe right about in here, there may or may not be a tsunami deposit. Harvey said he wasn't sure that it was in this photo, But what you can see is this area where it got a lot muddier because it sunk down and was then getting tide water into it, where before it had been fresh water. And so this looks kind of similar to what we see out on the coast for Cascadia deformation, but this is on a much smaller scale. This is an area, and not a very large area would have been subsided compared to what you get with a Cascadia event. The Seattle Fault earthquake, there's a lot of spectacular evidence for that event about 1,100 years ago. The southern end of Bainbridge Island was raised 26 feet during that earthquake. And the Seattle Fault also crosses the Sound, and where it deformed the seabed, offset, displaced a bunch of water and generated a tsunami. And the tsunami deposits from that event can be found in a few places. This is a photo of one of the places on the south end of Whidbey Island where this layer of sand here was deposited by that tsunami. This is a folding shovel, and these increments here are 10 centimeters. They give you an idea of the scale. A recent paper documents a fault that runs right along here in the Skipjack Island fault zone. And this fault there's evidence on the seafloor that this fault has moved and been active and potentially had enough movement to generate a tsunami. We don't know about when the most recent earthquake was on this fault, but the authors say that this fault offsets some sediments that were dated to about 6,000 years old. So sometime after 6,000 years, an event on this fault. So that's another one that could be tsunamigenic and potentially affect areas in Whatcom County. But like I said, there's so many faults. They're all these are just young faults that we know about, quaternary faults that we know about. And but I will tell you that most of the quaternary faults that we know about, we don't have enough information to tell you how often they have had earthquakes, or even if even if we know if they've had any. I mean, they have to have had some to be a fault, but we don't know when the last one was. Sometimes you can tell it's got to be fairly young because you can still see the scarp. And in this part of the world, with all the rainfall and vegetation, scarps can get obscured pretty quickly. So sometimes we just kind of looking for evidence. We might not be able to say exactly when these earthquakes happen. Okay, and then now moving on to deep earthquakes, deep source earthquakes. These are the kind of earthquakes we have the most frequently here. So 84% chance in the next 50 years. And this was like the Nisqually earthquake in 2001. And we have these a recurrence of 30 to 50 years. And like I said before, these are not going to directly generate tsunamis by uplifting or subsiding parts of the seafloor. But what they can do is trigger landslides underwater or into water landslides, which create tsunamis. And we know that this has happened. There's been some observations of this. These black dots are showing known tsunamigenic, tsunami-forming slope failures. And this one in Commencement Bay in 1894 was not triggered by an earthquake and caused a lot of destruction on the dock and some fatalities too. So these are probably the most frequent type of tsunamis that we get, and but they're very unlikely to leave behind geologic evidence in terms of a tsunami deposit. But it is possible to see evidence on the seabed, and this is also from that green paper. So Skipjack Island fault zone up here, the northeast side of Orcas Island is very deep here, and there's evidence for past landsliding, potentially off the side of the island into the water, which could certainly send a tsunami off to the northeast. And then another image from that paper is along the Fraser River Delta. There's some evidence for possibly a fault here in terms of a slump and some other pieces of deformation. So underneath all this sediment, there might be an active fault. And that's another possible, either the fault itself generating a tsunami directly, or shaking, letting loose some sediment that generates a tsunami. Now I'm now going to talk about Alaska. Whoops, I guess maybe I won't be able to. Sorry, that was an animation, but it's not working. Just take my word for it. Alaska tsunamis can travel across the ocean, arrive in Washington about 4 hours after the earthquake. And this map is showing about 100 years worth of Alaskan earthquakes. And each area here is showing the rupture area and magnitude and year for an earthquake. So this was the big one, magnitude 9.2 in 1964. And but a pretty remarkable thing to me is that there have been 82 observed tsunamis since 1788, and there was almost certainly a lot that weren't observed, or maybe were observed but not recorded by anyone in any way. So we definitely are concerned about Alaskan source, especially. That's sort of a direct shot to Washington. Of course, we can also get tsunamis from other places around the Pacific Rim, but they're the kind of the orientation, the way the wave will be propagating is not as likely to cause problems for us here in Washington. Now, there are places where there are tsunami deposits, and it's not entirely clear which one of these sources they come from. And so one place on Whidbey Island, Swantown Marsh, has 4 tsunami deposits, and I've got a picture of the 2 youngest ones. And the ages of these, so this is the road here along Swantown, and this is Big Marsh right here is where this evidence comes from. The ages of these suggest that they may be from Cascadia. And remember that Cascadia earthquakes had those letter names. So these are candidates for Cascadia U and Cascadia S. And it's not unexpected that the west side of Whidbey, right in the bullseye from the strait, would get Cascadia tsunami deposits. But what's kind of puzzling for this site is that there is no record of the most recent Cascadia tsunami from 1700, which we would expect to see, especially since sea level was lower when these 2 events would have occurred. So mysteries, sometimes more questions than answers. Another site that is really the most spectacular site in Washington in terms of tsunami deposits is Discovery Bay. So, Swantown and Discovery Bay are sort of on the way up to where you are in Whatcom County. At Discovery Bay, the big tidal marsh at the head of the bay there, if you know where to dig, you can unearth 4 tsunami deposits in the top meter of sediment there. So this is a meter stick, and these light layers are sand layers in this tidal marsh peat. And there are an additional 5 deposits beneath this that you can only look at by coring. And these have been, we think the most recent deposit is from Cascadia from 1700. And then beds 3 and 4, one of those is very likely Cascadia W, some of these older beds that you can't see, or maybe question mark correlated to Cascadia. But bed 2 does not have a Cascadia equivalent. Maybe. It doesn't, it's not exactly the right age to correlate to turbidite 2, and there's no evidence on the coast of Washington for any earthquake around the age of bed 2, which is about 600 years ago. There are also, I told you, 9 tsunami deposits in 2,500 years worth of sediment, and that's more than there are Cascadia earthquakes in that time frame. So some of these other sources are almost certainly represented here at Discovery Bay, and that's part of the work that I do. And I'm really hoping to, through a combination of modeling and improving the age dating of the events here, to try to get a handle on what some of these other sources might be. Okay. There is some new work in progress that I'm a part of in Bellingham Bay, and it's Tsunami Maritime Response and Mitigation Strategy Project, which is led by Washington Emergency Management Division, and also is being worked on by people in Department of Natural Resources and the Washington Geological Survey, Sea Grant, University of Washington, and City of Bellingham, the Port of Bellingham. You can read them all. And this is a pilot project, and the goals of the project are to use high-resolution tsunami modeling, even higher resolution than what you saw in those beautiful animations, to really get at what are the conditions going to be at port and harbor scales for the maritime community, to help the maritime community be well prepared and be able to make decisions in advance for different scenarios, tsunamis, different source tsunamis. And this is a pilot project, and hopefully this work will get duplicated for other areas moving forward. The work is not all finished yet, and so there'll be more to look at later. But one thing I can show you right now, this image on the right, this is current speeds, 2 hours and 20 minutes after the earthquake. This is not as beautiful as what DNR does when they get the data and churn out their gorgeous maps and animations. But this gives you an idea. And then also this is showing all the places where there are gauges for this modeling work, and you can see that they're really clustered up here along the waterfront. But some of the gauge output from the modeling, so this is for gauge 32, which is way out here, and this just lets you see what's happening on the surface of the water during the course of this tsunami model. And as you get close to 2 hours after the earthquake, you can see a drawdown of about 1.3 meters, so 4 to 5 feet. The surface of the water will actually be 4 to 5 feet lower, and then it'll raise up as the first and second waves come in, and then a big drawdown. So each one of these gauges will have its own record of what happens during the water levels during the course of the model. And we also have gauges that are recording water speeds. So that's still to come. And I know I gave you tons of information, and you may want more, and I'll just direct you to some of these really great websites. This NOAA website is a good place to start for information about anything related to tsunamis, especially if you're interested in warning, how the warning system works, what the different warning levels mean. If you'd like to see some of the latest tsunami research that NOAA is doing, there you can also go to the current tsunami status page that's run by the Weather Service. It's lots more educational stuff. And then the Department of Natural Resources tsunami page, which I've mentioned a few times. This is where you can go find all of those maps and animations. And then Washington Emergency Management Division helps to run the Tsunami Roadshow in Washington, which is a multi-city, multi-talk event. and they've archived some past talks. This year we had to do it online, which was fine, it worked out. And so you can go that site and look at all that, or you can always contact me too, and that's my email address if you have any questions or want to point me to any beautiful tidal marshes that you think I should come out and poke some holes in. And so with that, I will end and say thank you.
Thanks so much, Carrie. That was, it looks like all of those, all that time in school and degrees definitely paid off. Thank you for sharing all of that with us.
Oh, I don't know. I hope so. I'll be paying for it till I die. So I hope so.
So now we can open it up to questions. We have a couple minutes if folks have questions. I do see one in the chat box. So just as a reminder, you can add one into the chat box, or you can use the raise hand function, and we'll do our best to find you and call on you. So from Pete, he asks, Carrie, are local realtors monitoring these studies with the idea that low-lying areas such as Eliza Island may be inundated at any time?
That's a great question. I'm not aware of that. I think that they don't necessarily have to disclose this kind of information, but it's kind of outside of my wheelhouse. The only thing I can compare it to is I know that you kind of have to do that homework yourself to know whether you're sitting right on a fault line or something like that. There was a student at Western named Paige Morkner who found some tsunami deposits on Eliza Island. So we know there can definitely be some inundation in some places. I'm not sure if the tsunami goes over the top of the island or not, but it's something to consider.
Great. Next question is from Elizabeth. You had a point in Bellingham Bay for tsunami deposits. Where is that?
So the point is probably referring to the Birch Bay. Sorry about that. Probably referring to the Birch Bay location. There is a potential maybe tsunami deposit in Chuckanut Bay along the stream there, which I only looked at for a couple hours one day, and I am not 100% convinced that it's a tsunami deposit, but it may very well be. In terms of actually in Bellingham Bay, I'm not aware of any sites, but always interested in doing some reconnaissance work. A lot of places have been searched, but always interested in searching more.
Great, thanks. We have a few more questions. Sarah Brooke asked, can we get links to the DNR animations?
Yes, my slides will be posted, and that second to last slide has the URL for those animations.
Okay, and I got 2 of those links correct that I will add in to the comments, but the third one doesn't seem to be working for me. I think I mistyped it.
Or email me. Yeah, or email me and I'll send them to you.
We'll try to include those links too with the recordings and text, so it's a little easier to link to. So we still have time for some more questions. From Tom, I have a property interest right on the water in Birch Bay. In your presentation, it appears much of the work presented stops south of Birch Bay. Does NOAA have more info?
I don't think I've seen any, well, I know I haven't seen any tsunami modeling that goes up that far. The next version of the Bellingham tsunami maps will go farther up to the north, and it should include Birch Bay, and that work has not been completed yet. But John's going to talk after me, and he's got a little bit to share about Birch Bay, so maybe he'll help answer some of your questions.
Great.
Otherwise, stay tuned.
Next questions from Jeannie and Steve. And in Alaska, there were landslide-induced tsunamis, and I believe there were greater than. Oh, I'm sorry. Let me try that again. In Alaska, there were landslide-induced tsunamis that I believe were greater than 300 meters. Would you be more concerned about a landslide including tsunami for the Sailor Sea or a cascade-induced tsunami?
Right. So there are places in Alaska and also in the fjords of Norway where there have been truly spectacularly huge tsunamis generated by landslides. And so to get a tsunami like that, you need very steep terrain, and then water right next to it. And we don't have landscape that's quite like that. And most of the evidence for past landslides that we've been able to look at from like high resolution seafloor mapping, they don't look like huge events for this part of the world. And of course, if it happens right near where you are, it's a huge event. But in terms of 300-meter Lituya Bay kind of event, I don't know of any place. I can't think of any place offhand in the Sound where we could have something like that. But I can think about it. I could think about it, and if you email me, I'll let you know the results of my thinking about it.
Thanks. There's two more questions and then we're gonna have to move on to our other speaker. From Dirk, are you sharing this data with Whatcom County Unified Command so they can prepare, develop response plans for petroleum industries at Cherry Point, i.e. oil and chemical spills? Is your data being used to develop earthquake codes for building in Whatcom County? I assume that's what WC stands for. And maybe that's more of what John will cover, but.
Yeah, I think that once the maritime project's done, a lot of that stuff will get shared with people that need it. And in terms of building codes, I think I don't think anything that I've worked on will make any contributions to building codes. But in terms of like what we know about earthquakes, those get revised by USGS earthquake hazard maps, which play into how the building codes are affected. Somebody else who knows more about building codes can chime in, but as far as I know, the hazards from all of our local faults are considered when determining what those codes need to be like.
And one last question before we move on, and this might be again for our next speaker, but if you have a boat in the harbor, how long will you have to get it out of the harbor and where would you go? If
you have a boat in the harbor, you should get out, you should get to high ground. Because what the modeling is suggesting is that there's really not enough time to get out of the harbor, and you probably put yourself in a very dangerous situation if you try. I know people don't necessarily want to hear that because they don't want to lose their boat potentially. But if you have to make a choice between your life and your boat, hopefully you'll choose your life and just get to high ground. I know there are some ideas of making maps that show, if your vessel can go this fast, but you have to factor in the time it takes to get underway, and then there are not a lot of really safe places to go. And in some of the safe places to go, you have to cross across very treacherous places, and you may be crossing right when things get really bad. If you haven't seen any of those videos of boat captains trying to get their vessels out of marinas from Japan in 2011, email me and I'll be happy to send you some, because it's probably a really bad idea.
Well, thank you. There is another question in the chat box if you are able to maybe answer that, Carrie, by chat, because we do need to move on to our next speaker.
Okay, I will stop sharing now and I'll find it.
And John, if you want to start sharing your screen while I introduce you. So this seems pretty fitting. We learned a little bit more about the research on tsunamis, and now we get to hear a little bit more about our local action plan. So Mr. John B. Garrett, I'm sorry, John B. Gargett has over 35 years as a nationally and internationally recognized expert in risk, safety, security, emergency, and crisis management. He was one of the authors of the maturity model for the International Organizational Resilience Standard, developed new methodologies for risk assessment, and has testified before the U.S. House of Representatives. Internationally, he has worked and responded to disasters in over 45 countries, including risk assessments and planning for a wide range of threats and risks. He supported both the Indonesian and Japanese tsunami events. He has designed, conducted hundreds of assessments, evaluations, and exercises. His career has provided him with a unique insight into the problems of risk, safety, security, emergency, and crisis management from the perspectives of local, state, and federal governments, international agencies, developing countries, fully industrialized nations, the military, and the private sector. Mr. Gargett is currently Deputy Director for the Whatcom County Sheriff's Office Division of Emergency Management and Communications. So without further ado, John, please start your presentation.
Thank you. Can you see the screen?
Yes.
Okay, good. So I want to talk about the Whatcom County Tsunami Action Plan. And Carrie, I want to thank you for saying stay away from your boat if you feel the earth shake, because there really is no place to go that is safe. So thank you for that. So the Tsunami Action Plan, we have developed a Tsunami Action Plan. It has been developed over the last few years. It was published in December of last year, 2019. And basically, our approach is based off of the science that people like Carrie, and Carrie's done a fantastic job in presenting what it is that we look for in trying to assess the risk. But fundamentally, we have 10 major areas which we consider at risk from tsunamis in Whatcom County. And you can read the list there, but it extends from Bellingham Bay all the way up through Birch Bay, Drayton Harbor, and so forth. Now, the way that we've arrived at the risk assessment level is, I don't want to take a lot of time on the numbers. However, the bottom line there is our planning height, in other words, the level that we feel we need to plan to, is 20 feet. Now, that's based on the fact that the mean higher water is on average 9 feet in Whatcom County. The highest recorded is high water was 12.82 feet. And by the way, that was in Birch Bay, for those of you from Birch Bay. And the lowest observed water was minus 4.26, 4.25 feet. So we're saying, okay, on average, if we're going to have a 10-foot surge, yes, it could be 18 feet at the mouth of the Nooksack. It might only be 4 feet in Fairhaven. It might be, we don't know, but let's take 10 feet, and that's how we arrive at the 20-foot height. Now, when we look at the potential in Whatcom County for our tsunami areas, clearly, you know, Point Roberts, a lot of people forget about Point Roberts, but Drayton Harbor, this whole area right up in here is a very low area. And Carrie, you're welcome to come up here. We'll be glad to take you up there. I'll bet you could find some deposits there. Of course, Birch Bay, the Birch Bay area, the refineries, that was brought up in a question. And yes, we are working with the refineries on that, Sandy Point. And it's the Nooksack Delta really that has the largest physical area. And of course, Bellingham Bay has some as well as Lummi and the other areas. What I thought would be worthwhile would be to show you where we have existing sirens and where sirens are going to go. We've had an active siren program in Whatcom County for some number of years now. Point Roberts has one. There's one in Blaine. Down at the harbor, there's another one that was just delivered today that will be installed over on the Semiahmoo side. There are 2 of them in Birch Bay. One at Sandy Point. There's 2 on the Lummi Nation, one right by the casino and the other down in Hale Pass. And we're going to be adding a third siren right across from the ferry at the Lummi Nation as well. There's one currently in the Port of Bellingham down at the port facility, and we just took delivery on the second one for the port in Bellingham. So we've got a pretty robust siren locations. Sirens do not, however, tell everybody that there's going to be a tsunami. They are limited by wind speed, direction, humidity. There's a lot of factors, but it does roughly about anywhere from about, well, I'll say 3/4 of a mile is a good distance from there. And that we do have in place so that it covers most of the areas. The program is quite comprehensive. Our office is responsible countywide for the tsunami sirens and the tsunami system. All the maintenance on the towers themselves are done by the state of Washington and their engineers. And every first Monday of every month, you do hear the Westminster chimes, or those of you that are near should hear Westminster chimes that go off. That's a test that's conducted monthly along with an audio broadcast. So we do that intentionally so that you won't hear an actual siren. There was one instance for a number of you up in the Birch Bay, Blaine area on a monthly test when you heard the siren actually go off and it stayed ringing for some time. That was actually an error on another siren in White Rock. So it's amazing how the sound carried. It was a foggy day and the sound carried quite far. The tsunami alerts, there's 4 major ones: warning, advisory, watch, and information statement. I'll talk a little bit more about each one of those very quickly. The information statement basically says, hey, there's something that happened, letting you know that probably not going to be any tsunami. You can feel pretty good about it. In fact, we had one of those this morning, about 1:30 in the morning. There was a tsunami information statement for a 8 points. It was an 8 something earthquake over in Indonesia. So it just says there's no risk to our area. The tsunami watch statement is issued when it might happen, could be upgraded or downgraded, but that's where we would begin to take certain actions locally. The advisory statement is issued when we think we're going to get something. We're going to have strong currents, there could be waves, it may continue, it's a threat, it's taken quite seriously. We just don't know, but it's time to take actual actions such as closing beaches, evacuating harbors, and so forth, and marinas, evacuating harbors and marinas. Again, getting back to that question, if you feel the earth shake or there's an advisory or a warning, you need to get away from the water. Let your boat go, and I say that as a boat owner, I'll let my boat go. The warning statement means that there's a real big potential that we're going to have an actual tsunami, and that's where we'd actually begin evacuating the low-lying areas, all those 10 areas that I identified earlier. We would start that, but they can be confusing. So I want to talk just for a second about January 23rd, 2018, when many of us up here were woke up to our pagers going off because there was a tsunami warning, there was a tsunami watch, and we were right in the middle of it in Whatcom County, which means this: it was an 8.2 earthquake, but there was a tsunami warning for the entire coast of British Columbia, including the Strait of Georgia and all of Vancouver Island. They were literally beginning to evacuate Victoria, as well as coastal areas in the upper coast regions of British Columbia. At the same exact time, and it's amazing that right at the border, that warning stopped. Literally at the border, it turned from a warning to nothing in Whatcom County. But on our coast, the Washington coast, in fact, the entire West Coast, a tsunami watch was issued. So there's an example where our sirens might have gone off, they might not have gone off if it had changed, but we had to make a decision. So we actually issued that night, and several of you were up that night. We actually issued an advisory for our area, figuring, well, if we've got a warning to the north and a watch to our west, heck, it might be an advisory. It did all go away in just a few hours, but it does speak to the fact that we have to have a tremendous amount of interagency response and coordination. And especially in Whatcom County, we have to remember that we are on the Canadian border and we work closely with the Canadian authorities as well in terms of doing tsunami preparedness and getting ready for tsunamis in our area. I mentioned White Rock, that's the Semiahmoo First Nation. They have a siren, and we collaborate all the time in terms of testing, exercising, and so forth. Here's a list of just the stakeholders for the coast waters of Whatcom County. I doubt you can read all that, but just to point out, like in Canada, it's everybody from the Border Service Agency to the White Rock Fire and Rescue, Emergency Management, British Columbia, the RCMP. In Bellingham, of course, they have their own emergency management office, and Lynn Sturbins heads that. She's doing a lot of the work with that project we have going with the Port of Bellingham, which Carrie referred to earlier. But they're obviously taking care of the city of Bellingham. We have federal agencies. In Whatcom County, we have 4 different fire districts. We've got fire dispatch all over the place, law enforcement agencies, about 4 or 5 of those. It just really goes all out. Now, in the private sector, and I do want to mention this, there are a whole number of private sector organizations that are part of our coastal warning group, which we do have. And so that, from Semiahmoo Resort to Bellingham Cold Storage and pretty much everything in between, Birch Bay Village, they all get our updates and alerts, which are tested on an annual basis in the winter. We put out, and one of the reasons we put out gale warnings is to test and make sure that we have the right people in. Now, I did want to mention Birch Bay subzone. We've broken those 10 areas into subzone areas within Whatcom County. And what you're looking at here, the red area, we're using elevation from the county GIS system. That is the 20-foot elevation level in our coast. Now, again, please do not confuse, and we're not saying that this is the area that will be inundated. We're simply saying that if we had a tsunami and it occurred at high tide, average high tide, these areas could get water. We're not saying they would be swamped. We're not saying any of that. We're just saying that this is an area that has the potential for it. Now, you might notice up there that just in Birch Bay alone, these numbers we just pulled out today out of the county GIS database, there's 2,762 land parcels or properties in the Birch Bay subzone in the 20-foot or less elevation level. And that represents about 4,100 different structures, garages, buildings, etc. According to all the population figures for 2020 from the census, and that's incorporated in there, there's about 4,800 people that live in that threat area. Most surprising is the property valuation, the market valuation in Birch Bay in that 20-foot or less elevation is nearly $500 million. And we have an estimated about $600 million in total value. For example, the marina in Birch Bay Village, cars and other structures such as the Birch Bay water and sewer system. So that's just an idea of what's there. Now, the siren at the park covers most of that area there. There is a second siren in Birch Bay Village. That takes care of that area. We do have pre-identified roadblock locations, pre-identified for the sheriff and to blockade the roads, preventing anybody from entering the area. It would also be blocked by fire personnel as well. And we have evaluated and determined that we can get these roadblocks in place within 10 minutes of a warning. That's to enable people to get out, of course, not let people in. We also have assembly points in Birch Bay. Again, there's 3 of them, so we would urge people to go to the assembly area. Assembly areas are not shelters. That's a place to go to get information. So you would go there. We have pre-identified individuals. A lot of our volunteers, amateur radio community, our community emergency response teams will go to those areas and help get you directed to where you would need to go. So it does get complicated pretty quickly. Again, if you look at the total amount of valuation, roadblocks, people, getting them out, getting 5,000 people out in 2 hours is a daunting task. And that's only part of our overall hazard area. So again, we would be executing our plan in all of these areas simultaneously. I just wanted to show you what Birch Bay looked like. Now, when I talk about the plan itself, and again, this was published and signed off by the executive last year, we have very specific checklists. This is one of the lessons we've learned from, frankly, Japan, is exactly who's going to do what. And these have been published and signed off on by the appropriate people. So this happens to be a warning checklist for organizations. So there's, I know you probably can't read them all. We're not going to try and cover them all, but there are specific tasks which people need to, and these organizations need to execute against. We have pre-scripted messaging. These messages, as you can see, again, probably can't read it, but for example, the message 301 is for an advisory. And we get our warnings from the National Warning Center in Alaska, and that's where we get them. And so we would simply fill in the appropriate information and get this out on social media to the local media sources, newspapers, radio, etc. And then we have them for all the other variations of that. Now, one of the things that we're pretty excited about is we've done the plan. We're in the process of updating the plan. And I will tell you that part of that update is taking the information which Carrie and I know Kurt Baumgardner from the Port of Bellingham and Lynn Sturbins from the City of Bellingham, all working on this tsunami mitigation effort. The outcome of that is going to help drive our update this year and next year, 2021. But the last element there, the exercise, and by the way, that's part of planning. You have to continually update it. The day you publish a plan is the day it's out of date. So you begin to update it. And we are doing that. And we're doing that with some of the students and interns from Western Washington University to literally go through and provide that information that I just gave you for Birch Bay for all 10 of our areas that are at risk. But in 2022, there's a major exercise called Cascadia Rising, which is an earthquake exercise. Whatcom County is not going to participate in the earthquake per se. We're going to participate by having a tsunami exercise, and we will exercise the plan in full in 2022. And our plan at this point is to actually evacuate our coastal communities to get a baseline on how long it actually takes to accomplish that. So that planning has just begun, and you all can wait and hear more about that into the future. I know time is short, so I want to just kind of conclude it there. And I do want to tell you that this graphic here, I stole it. It's not my graphic. It came from the Department of Natural Resources, Washington State. So I want to say thanks to Karina Forson for the one that I'll give credit to for making that. But in emergency management, if you can steal something and give somebody else credit, you want to do that. So with that, I'd be happy to answer any questions that people might have. I will tell you that yes, tsunami inundation levels are reflected through the FEMA firm maps, the flood inundation maps. So coastal communities in Whatcom County, if you're building near the coast, you have to comply with that. A little bit different than tsunami depth height, but fundamentally, if you're near the water, you have to meet that requirement, and that's 14 feet, by the way, is the level that they have on that. And yes, that is incorporated into the planning department and used as part of a permit process when you go through to get a permit, and that also includes the earthquake restrictions. So with that, Eleanor, I know time's short, so I just thought I'd give a quick overview that we're not unprepared here. I think we're very prepared.
Thank you so much. We do have, I see 3 questions. So the first one, this was put up before you started talking about Birch Bay, but Colleen said, hi, my question is about the community of about 100 families off Deer Trail in Birch Bay. The only exit is for the entire community to drive towards the beach before they can get out or get to the exit on Shintaffer. a poor plan and unnecessary. An exit for the entire community could be easily provided by extending off Pheasant about 100 or 800 feet along the back of the community to join up with Shintaffer. Do you have any thoughts on that? Or
Yeah, I'd love to see that happen. Actually, I know that community quite well. I know that issue well. We've addressed it. It is been turned over in terms of process to the Whatcom County Public Works Department to include in long-range planning to be able to see if that can happen. That is a private development that was put in with only one ingress and egress. It's not the only one, unfortunately, in Whatcom County. We have about 6 of them like that, including all of Sandy Point.
thanks. I see. So I'm going to ask a question in the chat box, and then I was going to call on Amanda, but looks like she put it into the chat box. So Dan's question was, how are the sirens powered? Is there a risk that they will not work if an earthquake results in power outages?
A good question. And no, the sirens actually will, if they're actually, well, first of all, they're on power. Yes, they're hooked up to power. So as long as power exists, they will go off. However, they have battery backups built inside them that will last for approximately an hour and a half. So if power is lost, the sirens will sound for about an hour and a half to 2 hours. It just depends on how old the battery is. Those batteries are changed out on a regular basis. In addition to that, the sirens are set off in one of 3 different ways. One is telephonically, the other is via satellite. That's how we test it. We set them off via satellite every month, and we do that locally here. And the third way is via a handheld radio. And ourselves, fire department, Port of Bellingham, we all have handheld radios and can actually set them off locally if need be.
Thanks. Amanda, you have your hand raised, but it looks like you typed in your question. So unmute yourself if you want to ask your question verbally. Otherwise, she asked, how is Whatcom County using these maps to guide development, specifically the anticipated development on the Beeham waterfront?
Right. So the development down at the waterfront is that falls under the permit authority of the city of Bellingham. And so that I would direct that question to the city of Bellingham. However, the quick answer to that is yes, they are being considered in terms of the elevation and the types of elevation of the buildings, as well as the mitigation measures necessary for an expected height.
And through my work at Resources and the 12 MACA sites, Model Toxic Control Act sites, I know in the MACA, they do have to account for things like that. So those contaminated sites, when they're cleaned up, they do think about tsunamis and earthquakes and other things like that, and sea level rise. And one last question from Margaret. I live near Dakota Creek. Will I be able to hear the sirens from Semiahmoo?
Dakota Creek is probably on the edge now. I don't know where Margaret lives in Dakota Creek. If it's right
the mouth.
At the mouth, yes, she'll be able to hear it. She should be able to hear it. Now, if we have a strong south wind and it's raining, it's possible, sound waves do react to the natural environment as well. So, it's possible she may not, but if she's at the mouth of Dakota Creek, especially after the second siren is installed, I'd be pretty surprised if she didn't hear it.
Great, well, thank you. Usually this is the time when we clap for all our speakers. Thank you so much, John, and thank you so much, Carrie. We really appreciate you guys sharing all of your knowledge. It's been really wonderful having you guys here. I pulled the trigger a little early because I was afraid I would forget, but in the chat box, I did include some links, and then I included a link again on survey that we would like you to take to help provide feedback so that we can better serve you with events like this in the future. We also have a link for where you can find the recordings in the future from this presentation if you want to rewatch it or share it with some friends. And the other link is to the Whatcom Watershed Information Network website. And on the left-hand side, there's a button that you can click on to sign up for emails to find out about more events like this. And Cheryl or Austin, let me know if I forgot anything. And if you are an MRC member, please definitely stay on. But at this time, if anyone wants to hop off because they don't want to listen to the MRC talk about green crab in our July meeting, that's totally acceptable. We don't mind. But happy to still have you here. And thanks so much again for everyone for joining us and tuning in.
Well, I want to thank you all. And if anybody has any questions, you can contact me at the sheriff's office. Thank you.
Thank you.
Thank you.
Feel free to contact me too.
Thank you, Carrie.
Thanks. Bye-bye.
All right. So I'm going to keep going, but maybe because it's been a little over an hour, feel free to stand up and stretch out or do, shake it out, whatever you need to do. We'll try to get through this next section fairly quickly. So if you don't have the MRC agenda in front of you, I will put that link